Hi everyone. In section 5.5 we're going to be performing function operations, and that is to say we're going to take two functions and add, subtract, multiply, or divide them. There's definitions and examples here that you can pause and look at if you like. But if you just take a look at the definitions, if we say what is f plus g of x, that's the same thing as saying what's f of x plus g of x. You can see how those functions come together over on the right. Another question that's going to come to us, it regards the domain. Domain speaks of what the possible x values are for a function, and you can ask that question from a positive or a negative perspective. Negatively speaking, we can ask, are there any restrictions on the domain? So when you take a look at these examples, 5x and x plus 2, you can see that there's no restrictions. We can take any number in the world and multiply it times 5, and we can take any number in the world and add 2. So when we add, subtract, and multiply, there's no restrictions on the domain. But sometimes when we divide, if there's an x in the denominator, it presents a restriction for us. So you can see here when we divide f by g, x plus 2 is in the denominator, so x can't equal negative 2 in that situation. And also just note that this is f plus g of x is to say that we are going to combine these functions and then evaluate some value of x. I have seen in the past that some people just think for some reason we're going to multiply times x, and that's incorrect. So let's look at a few examples of adding and subtracting functions. We'll state their domains, and then we'll evaluate given a certain value. So in example 1, we have f of x equals negative 1/2 times the cube root of x, and g of x is 9/2 times the cube root of x. So if we are to add those, what we want to do is take both of those expressions and combine them. Are they like terms? Yes, they both have the cube root of x. So we talk about negative 1/2 plus 9/2, that gives us 8/2, or simply 4 times the cube root of x. Now we want to state our domains, and that is to say, are there any restrictions? Is there anything that we can't take the cube root of? No. So our domain goes from negative to positive infinity. All real numbers are possible. When we evaluate, when x equals negative 1,000, we simply plug negative 1,000 in under the radical sign. That's equal to negative 10 times 4 gives us negative 40. Please note it's possible to evaluate f of negative 1,000 and g of negative 1,000. When you do that, you would come up with 5 and the negative 45. Add them together, you would also come to negative 40. In this lesson, we're going to combine the functions first and then evaluate. When we go to subtract, it's a similar situation. Now we're going to subtract negative 1/2 minus 9/2, so that should give us a negative 10/2, which simplifies to negative 5. We still have the cube root of x. Once again, we can take the cube root of any number, so there are no restrictions. And when we insert negative 1,000 into our expression, we should get negative 5 times negative 10, and our final answer is 50. Second example, can we add f plus g of x, and also can we subtract f minus g of x? For addition, we set up our two expressions alongside one another. Notice, I don't know that it helps, but I put the g of x into standard form, keeping the negative sign with the 3x squared, positive 6x. When we blend our terms together, we come up with a nice trinomial, and we ask ourselves with regard to the domain, is there anything that we can't square or multiply times 3? No, we go from negative to positive infinity. If we want to evaluate when x equals negative 1, we simply take that trinomial. Wherever we see x, we plug in a negative 1, and we perform the order of operations. So negative 1 squared is positive, 3 times negative 1 gets us to a negative 3, and when we blend these together, we come out with a value of 1. If we were to graph this function, this trinomial, when x is -1, y would equal 1. -1, 1 is a point on that graph. Let's subtract. We'll take our two expressions and we subtract the g of x. So make sure we deal with our signs. -x squared plus 3x squared will get us to a positive 2x squared. Similarly, we're going to have minus 3x and minus 6x gets us to minus 9x, and the 8 still remains positive. Once again, there's no restrictions. We can plug any number in the world in and square it or multiply it times -9. So if we evaluate when x equals -1, we simply insert a -1 wherever we see x, we simplify, and we come to our answer of a positive 19. One more example dealing with the fourth root. Let's add these together. When we do so, it's nice because we do have some like terms here. 5 times the fourth root of x and -3 times the fourth root of x, those are like terms, and 1 and -2 are both constants. So when we blend these together, when we combine like terms, we get a positive 2 times the fourth root of x, and we get a -1. The domain restrictions this time around, just think, is there anything that we can't take the fourth root of? It's the same answer as is there anything that we can't take the square root of? We can take the square root or the fourth root of 0, but not anything negative. So when we consider our restrictions, we're going to say that we can go from 0 to infinity. And if you notice on the left-hand side, there's a bracket there saying that 0 is okay. We can take the fourth root of 0 and anything greater than that. The interval notation on the left is probably the preferred way to express that, but it's also true to say that x can be greater than or equal to 0. Now let's evaluate when x equals 1. So we're going to have 2 times the fourth root of 1 minus 1. That's simply 2 minus 1, and our answer is 1. When we go to subtract, we are going to subtract everything from g of x, which means that we want to make sure that all of the signs change. So 5 plus 3 gets us to 8 times the fourth root of x, and 1 minus a -2 gets us to plus 3. Again, the restriction is the same conversation as over on the left. We can take the square root of the fourth root of 0 or anything positive, but nothing negative. When we insert a 1 into our expression, we're simply going to be left with what is 8 plus 3, and 11 is our answer. For this next set of directions, we're asked to both multiply and divide two functions and state their domain, and then evaluate them when given a certain value. So for number 4, we have f of x and g of x, and we're asked to multiply them together. When we do that, you can see the negative and the positive 2, multiply them together, and we should get -2. And then when we multiply two x's together, we can add their exponents. What we should do first is convert the cube root of x to x to the 1/3 power, and then switch over x cubed so that there's a common denominator, and realize that the expression should become -2x to the 10/3. Are there any restrictions on the domain? Well, we can cube anything, and we can also take the cube root of anything, so no, we can still go from negative to positive infinity. Finally, when multiplying, we're asked to evaluate what's the value of the function when we insert a -64. Well, I broke apart the exponents so that you could see that the cube root of -64 is -4, but -4 to the 10th we wouldn't hold you responsible for knowing. That's a calculator problem times -2. It turns out to be -2,097,152. When we divide, we put one expression on top of the other, and we divide the coefficients, -1 divided by 2, and x cubed divided by the cube root of x. Similar to when we multiply, we bring those into one single variable, but this time we subtract the exponents. So 9/3 minus 1/3 should give us 8/3. When we divide, we get negative 1/2 x to the 8/3. Were there any restrictions with the f of x or g of x? No, but we can never divide by 0. And when we put that red expression g of x in the denominator, if x equals 0, that's going to turn the denominator into 0, and that's a restriction. So a quick way to express this is that x can't equal 0. A better way is to use interval notation and say that we can have all values from negative infinity to 0 and from 0 to infinity. The parentheses around the 0 say that that's exclusively, we don't want to include the 0. And finally, when we evaluate when x equals negative 64, we plug that in for x. The cube root of negative 64 is still negative 4, but negative 4 to the 8th times negative 1/2 is a little bit too big for us to do in our heads. The answer is negative 32,768. For number 5, we again want to multiply and divide. Let's multiply first. When we do that, we are talking about 1/4 times negative 4, and we're talking about x to the 1/3 times x to the 3/2. That will simplify to be negative 1 for our coefficient, and then when we talk about x times x with different exponents, we add them together for multiplying. We have to find a common denominator, so 1/3 can become 2/6, 3/2 can become 9/6, and so that should simplify to negative x to the 11/6. When we talk about the domain, is there any restriction from f of x? No, because 1/3 is equivalent to taking the cube root, and we can take the cube root of anything. But when we look at g of x, do you see that the exponent is 3/2? The 2 in the denominator is talking about taking the square root, and we can't take the square root of negatives. So we are going to say that our domain is going to go from 0 to infinity. The bracket next to the 0 says that 0 is a possibility. We can take the square root of 0, we can take the 6th root of 0, but nothing negative. We're also asked to evaluate when x is equal to 1. So if we plug in a 1, the order of operations says that we should raise it to the 11/6 power first, so that should give us just a 1, and then multiply times the negative, so our answer is negative 1. When we divide, we're going to put the numerator as f of x and the denominator as g of x. When we consider our coefficients, 25/100 is like 1/4, and if we're going to divide by negative 4, it's like multiplying by negative 1/4, so that's going to give us a coefficient of negative 1/16. When we divide x's, we're going to subtract their exponents, so it's similar work finding a common denominator, and then we're going to come up with negative 1/16 x to the negative 7/6, or if you would like to put that variable down in the denominator so that it becomes positive, that's a good idea, particularly because if we're going to talk about the domain, not only can we not take the 6th root of a negative, but now x is in the denominator and we can't divide by 0. So it's a subtle but important difference with these domains. There's a bracket over on the left side when we were multiplying saying that 0 is part of our domain. Now the parentheses say that it isn't. There was an x is greater than or equal to symbol, and now it's strictly x is greater than. When we go to evaluate, what happens when we plug in 1 for x? The order of operations says take 1 and raise it to the 7/6. That's 1 times 16, so we get 16 in the denominator, and our final answer is negative 1/16. We have one more example of multiplying and dividing. We have some rather large onerous numbers here, but the process is still the same. When we go to multiply these, we're going to multiply the 36 times the 4, and also x times x, where we're adding those exponents together. So we get 144, and I converted 1/2 to 2/4, So we should see that as 144x to the 9/4 power. Are there any restrictions here? I'll leave you a second to think about that. There are, because both denominators for the exponents, we have 7/4 and we have 1/2. That's the 4th root and that's the square root, and we can't take an even root of a negative, so we go back to having that bracketed 0 saying you can take an even root of 0 and anything positive, so from 0 to infinity, but nothing negative. We're asked to calculate when x equals 16. If we plug that in, you can break apart the exponent of 9/4 into 1/4 and 9. By doing that, the 4th root of 16 is 2, but 2 to the 9th I don't know off the top of my head, and then I want to multiply that times 144, so I will grab my calculator to come up with 73,728. But I wanted you to see that we can simplify things sometimes. When we divide, it's f of x divided by g of x. So this is a little bit nicer in that it's going to be 36 divided by 4. And when we divide with x and x, we're going to subtract our exponents. Again, I switched the x to the 1/2 to x to the 2/4, so that when we simplify, we come to a nice 9 as our coefficient and x to the 5/4. Are there any restrictions here? Well, again, we have the same restrictions as before in that we can't take the square root of negatives, but we also are dealing at some point with x in the denominator. Do you see at the very beginning when we had the blue and the red? When we had 4x to the 1/2 power in the denominator, if x was 0 at that point, we would wind up with something undefined. So just like in the last example, when we're dividing here, our restriction for the domain does not include 0. We're going to go from 0 to infinity, but 0 is not part of the solution. And finally, when we go to evaluate, when x equals 16, breaking apart the exponent here makes a little bit more sense because the 4th root of 16 is 2, and 2 to the 5th equals 9. 2 to the 5th equals 32, and 9 times 32 gives us 288. And one more example for this lesson. The variable x represents the number of pages of a textbook to be printed. The cost to print a textbook can be modeled by the equation c of x equals 2/10 times x squared plus 10, and the selling price p of the textbook can be modeled by the equation p of x equals 5/100 times x squared plus 20. Find p minus c of x and then explain what that represents. Well, similar to the last set of problems when we were subtracting, we just simply write out what was p of x and we subtract c of x. You want to be careful with distributing that negative sign. We'll wind up with negative 15/100 x squared, and 20 minus 10 is going to give us 10. That means that the selling price minus the cost represents the net income or the profit of selling textbooks. There's a graph over on the right. It's suggesting that as x, the number of pages, increases, the profit decreases. Your homework for this lesson is 5.5 puzzle time. It will be posted in Teams. There are 12 problems, and there is an answer key over on the right. If you are working properly, you should match your answers over on the right, and that'll help you answer your puzzle. Have a great day.